And welcome everybody to the Daily Space Weather, just bringing you the most detailed imagery of the sun and comprehensive space weather you'll find anywhere in the known universe here at the Smash News Network, least busted name in news. We're starting things out looking at the sun in 304 plus 193 angstroms. Why? Because it's great at showing filaments. And there are some filaments on the way to Earth as we speak. We're expecting a CME impact both tomorrow and Thursday, and we're seeing a current coronal high-speed wind impact. We'll get to that later in the video. First, let's go around the horn as there are lots of interesting features to take a closer look at. So first, we'll start out by looking at these prominences around the north heliographic polar region. Some plasma up there suspended by magnetic fields, and you can see some plasma rushing past our field of view there. That's one of the CMEs that's not headed in Earth's direction. Let's go around the horn real quick. Here's what's going on in the northwest. The southwest. There is at least one huge plasma filament over there. Let's head to the southeast. Check out the size of this plasma filament. That one is large. Also a coronal hole trailing it. We do have at least one new sunspot group today to get a name. We'll also show the northeastern limb. And by the way, if you enjoy the content, don't forget to press like, subscribe, share, etc. Tell your friends and foes about us. Leave us a nice comment. Leave us a mean comment. It won't hurt our feelings here at the Smash News Network. Least busted name in news, and thanks for leaving comments. Tinman1057 and Mike Bordages. Good morning to both of you dudes. Thanks for tolerating the censorship on the platform of YouTube. And happy, I'm not going there. However, today's featured product is Do the Math. If you're frightened of the galaxy, or maybe even of the sun, maybe you ought to get out of space weather entirely. If you're a channel who is spouting nonsense about astrophysics and cosmology, please resign. Please exit the space entirely and do the math. The galaxy is not going to kill you. It's very big. And the stuff going on at the galactic core is very scary. This Do the Math product does indeed feature the galactic core of the Milky Way. That's multiple wavelengths there. I believe that's the Hubble and the Chandra imagery of Sagittarius A star. The Milky Way's galactic core. It's right in there somewhere. And if you're worried that the galactic core is going to kill you, please take Physics 2 and do the math. Everything is not electric. Otherwise, we wouldn't need the term. If you visit the links below the video, you'll find our Redbubble shop. The products are in there in order of best selling. Our best seller is Do Not Pole Vault the Caldera. We've got multiple different Do the Math designs. This one features Alpha Cygni, the brightest star in the constellation Cygnus, known as Deneb, and we believe it to be the most important star in the entire Milky Way galaxy. We'll tell you on a different video why that is. Let's get back to some additional space weather info here. Here's yesterday plus today in SDO intensitygram. So again, we do have at least one new sunspot. It just spontaneously formed right about here, close to the equator. Also one up here. So it looks like at least two new named sunspot groups today. Here's your colorized magnetogram for that same time span. That's yesterday plus today so far. So at least two likely new named sunspot groups today. And let's take a look at Crescent Earth's situation. There's a volcano erupting. That's Fuego. And let's see what else is popping off in terms of new real estate and so on. So Shivaluch is erupting once again in an explosive fashion. It's producing a 13,000-foot plume of volcanic ash over Kamchatka. It's a flight level 130. Flight level 070 over Sakurajima. Flight level 060 over Subanose-jima. Merapi, flight level 150. It's a 15,000-foot ash plume as Merapi explodes. Popocatépetl exploding. Flight level 220. It's a 22,000-foot ash plume. About a 16,000-foot ash plume over Fuego there, following lava fountaining and other incandescent material being ejected to a few hundred meters above the crater. Also glowing avalanches toward Sanitza and Santa Teresa and Honda Chutes. Nevado del Ruiz exploding, flight level 200 over Colombia from Nevado del Ruiz. Not sure about Sangay in Ecuador, but Sabancaya is producing intermittent puffs of volcanic ash. Please do not pole vault that caldera. It could be unhealthful. Let's see what's going on in terms of global seismicity. There's your 90-day bar graph. There was one significant quake over the past 24 hours. We considered putting out an email alert about that, but we didn't because of the extreme depth of the quake. So that was a 6.3 there near Papua New Guinea. There is the location of that. We do send out email alerts to those signed up for email alerts at smashomash.com/smashteam. More information about that toward the end of the video. There's the location. Again, that's a 6.3 magnitude quake. It was at a depth of over 213 kilometers. Exactly 213 kilometers estimated depth there. That one came in at 0:49 this morning, Universal Time. So let's just go up the list here. We'll cite quakes that are above a 5 magnitude. And another quick reminder, like we say most days, any earthquake can be a foreshock, like this 5.0 north of New Zealand, in the Kermadec Islands region there, adjacent to the Kermadec and Tongan trenches, a trench that stretches between New Zealand and, is it Fiji? Tonga. It's Tonga. Anyway, also there was a 5.1 here at Peru. That was also quite deep at 103 kilometers. A 5.0 at the Solomon Islands also occurred yesterday evening, Universal Time. And then we saw a 5.2 at Argentina there, south of the Peruvian quake. And then that 6.3 came in at 0:49. The estimated depth there, 213 kilometers. And then no quakes over a 5 magnitude, except for this one here in southern Kamchatka, a 5.0. And let's get back to space. By the way, we got a cosmic ray report coming today. Here's the sun, last 24 hours, 211 plus 171 angstroms. And those are some sweet wavelengths. Let's swap out the 211 angstroms. Let's get rid of the 211 angstroms. How about that? There's just 171 by itself. And the 10.7 centimeter radio flux has dropped all the way down to 143 solar flux units. Those of you not familiar with the 10.7 centimeter radio flux, it is the most proportional data set we have to sunspot number, as you may be able to see on this graph comparing the black line and red lines. The black line is the radio flux, the red line is the sunspot number. And yeah, a big decrease here in solar activity. And the Space Weather Enthusiast dashboard is forecasting a geomagnetic storm early tomorrow and early in the day on Thursday, March 16th. So 2 CME impacts. I'm not so sure about the one tomorrow, but pretty sure about the one on the 16th. So again, we are currently seeing a coronal hole high-speed stream also. We'll cover the stats on that in a moment. That's your Space Weather Enthusiast dashboard there, which is, by the way, part of the Space Weather Prediction Center. All kinds of interesting information in there. We're also seeing a solar energetic particle event continuing. First, let's take a look at Earth's magnetic moment from space for the past 4 hours. So there's our magnetohydrodynamic pressure. Again, we've got a coronal hole high-speed stream here just setting in. It's not looking particularly powerful, but that's what's going on in Earth's geospace. That's Earth's magnetic moment to about 12 Earth diameters, magnetohydrodynamic pressure. Next, we're going to show ground magnetic perturbations. This is Earth's magnetic moment from the ground. And since we are seeing a little bit of an uptick there in activity, we are showing the geospace delta B for North America. So that's the last 4 hours of likely places for aurorae. It's also going to show you the most likely places for pipeline, railway, and power grid induction, telluric currents, etc. We normally only show the global map, but when we're having times of excitement, especially geomagnetic storm and geomagnetic unrest conditions, we'll start showing the Geospace Delta B North America map. Perhaps it'll give us insight that we're not even looking for, as in the realm of science, we often end up with answers to questions not asked. So anyway, here's Earth's magnetic moment from the ground for the past 4 hours on a global scale. Let me bring that slider back. Might as well just let it play through by itself. All right, so here's the last 4 hours. And if you're wondering if I think Earth's magnetic poles are going to flip, the answer is categorically no. The likelihood is shockingly low, statistically speaking, and Earth's magnetic poles are much more likely to snap back toward the geographic poles than they are to continue with an excursion. Let's continue on to Earth's global geomagnetism average, the KP index. And there you go, KP3 is the current situation. We could see a rapid change here to geomagnetic storm conditions depending on what happens. So let's take a look at what's going on with the real-time solar wind to see if we can make any predictions for that. Keep in mind the real-time solar wind is measured outside Earth's magnetosphere at Lagrangian point 1. There are the data from, that is just the Discover. You see the blue line down there indicating it's just the Discover. So we did see the solar wind density make it up to about 25 protons per cubic centimeter there, about 26 protons per cubic centimeter. I believe that was the peak. So the standard fair incoming coronal hole high-speed stream there marked by an increase in the density and then an increase in the speed as the density drops off. So we are expecting the speed to get a little bit higher than this. Well, that might be it. That might be the peak, as we are seeing a leveling off of the plasma temperature there and the solar wind speed. So it's a pretty weak coronal hole high-speed stream at the moment. Current conditions still elevated for the solar wind density, so we may see that drop off a little bit more. Current conditions are 18.2 protons per cubic centimeter. Solar wind density 18.22. Solar wind velocity 428 kilometers per second. And if we do see, we are getting a little bit of a stronger field. We did see a stronger field here at first. We did have a field of a BT 15 nanotesla there, but that has been subsiding as the density wave subsides and the high-speed portion commences. So at the moment, got a nanotesla of 9 and a BT of -2. If we see that BT drop to like -5, we may see geomagnetic unrest conditions commence, or even a mild geomagnetic storm. But this is looking like a fairly weak coronal hole wind stream so far. Next, looking at magnetic data. So these are your GOES magnetometers. The GOES magnetometers are geosynchronous orbiting near equatorial satellites. They're at like 23,000 miles of altitude, so they are way up there. And we are seeing some rapid shifts in that, as are typical of a coronal hole high-speed stream impact. Next, we'll look at the heliospheric current sheet, and Earth is currently in a North Pole current sheet. The current sheet is North Pole oriented, shown here in green. So there's your North Pole current sheet. South Pole current sheet, for the most part, on the opposite side of the sun here. And no major changes here happening in the past about day. Keep in mind that does show 5 days. We'll also take a look at the line of sight field plot. Here you can see the sun's B field in blue, solar polar fields in red for south and green for north. And let's move to coronal holes. So the coronal holes that are currently affecting Earth are North Pole oriented, shown there in green. No surprises there. We do see some red ones sneaking through on the southeastern limb. That one's probably not visible yet. Let's take a look at 211 angstroms. So down here, there is one that will come into view here shortly. And quick reminder about solar cycles, by the way. We still see lots of North Pole magnetism at the North Solar Pole and some South Pole magnetism at the South Solar Polar area, the South Heliographic Polar area. And those need to leave and reverse in order to complete the solar cycle. So one of the many reasons why we keep saying there's a long way to go. This is the past 24 hours and 211 angstroms wavelength. It's probably the best single wavelength to show coronal holes. And let's move to sunspots before we talk about cosmic ray flux. So here is our sunspot section. Again, we've got at least one new sunspot group. I think it's going to actually be two. This one right by the equator, and then there's one up here to its northwest, I believe. There might be a third one down here in the southeast. Let's take a look at the past 24 here in 171 angstroms plus SDO continuum. Let's zoom in a little closer. So what's great about this is that it's going to show you those active regions in the 171 angstroms and also the umbrae in the SDO continuum. Let's subtract the 171 angstroms. So at least two new sunspot groups likely to get names today. Don't expect this downtick in solar activity to last very long because, again, we've got a ways to go to get to solar maximum. So let's move on to cosmic rays. Yeah, now if you're wondering what a cosmic ray is similar to the components of the solar wind. So cosmic rays are primarily made of hydrogen nuclei, and they are, what we refer to as a cosmic ray is primarily hydrogen nuclei that are blasting through space at a significant percentage of the speed of light. So these are measured at the ground level via their particle showers, as they create neutrons and so on. And so cosmic rays are super important since cosmic ray flux is inversely proportional to solar activity. So when we look at solar cycles, we see high cosmic ray flux during solar minima and low cosmic ray flux during solar maxima. Anyway, here's the report. So cosmic rays are made of basically the same thing as the solar wind. They're just not coming from the sun, primarily. So anyway, this is DOMB's cosmic ray monitor. This is a neutron monitor, and we've had an uptick in cosmic ray flux over the past 30 days at DOMB Antarctica. So that's interesting. Here's DOMC Antarctica. We've seen an uptick there over the past 30 days as well. And also at Oulu, an uptick in cosmic ray flux over the past 30 days. Now, there might be channels out there that are spouting nonsense about cosmic ray flux, that it's the highest that it's ever been measured, and it just isn't. Because at the previous solar minimum, the solar minimum between solar cycle 23 and solar cycle 24, cosmic ray flux was higher, as you can see right here on the Oulu graph. And we are way below that now. And we're expecting to go all the way down to somewhere around here by the solar maximum of this cycle. So cosmic ray flux is an inversely proportional data set to sunspot number, for example, or the 10.7 centimeter radio flux. And let's look at some more monitors here. Oh, also, by the way, the Oulu monitor has a great GLE page. That's a ground level event where solar particles make it all the way to the ground level. If you want to look up information about those, it's got the different monitors' measurements of those. So check out the Oulu Cosmic Ray Station if you like. Click on GLE and you can look at data sets about ground level energetic particle events, ground level events. Let's take a look at some other monitors here. We've also got a mild uptick at Mexico City for the past 30 days. So that might be interesting to you. Cool thing about the Mexico City Cosmic Ray Monitor is that you can look at historic data. So if you want to show somebody how cosmic ray flux is much lower than it was at the solar cycle 23 to 24 transition, you can bring up those data sets. Just bring up to about 2009 or 2008, and you'll see obviously higher cosmic ray levels at that point in time. But for the past 30 days at Mexico City, we have seen an uptick. Now looking at Athens, Greece. So Athens, Greece here, also showing an uptick in cosmic ray flux over the past 30 days. And here's another great thing about Athens Neutron Monitor. you can actually bring up the neutron monitor database here. And if you click on data, it'll open up this page. Wait a minute. That doesn't look right. What happened? There we go. There's the cosmic ray data page, and you can bring up your favorite cosmic ray monitors. So let's take a look at, we'll put up DOMB Antarctica, we'll put up Athens, and how about Mexico City, and how about, oh, I don't know, Oulu, Finland? There's Oulu. And let's put up, just to show you that cosmic ray flux was much higher around 2009. Let's do this date in 2009 until today. So there you go. Back in 2009, you can see cosmic ray flux was much higher than it is today on every reputable monitor. So you can bring that up if you like. Again, that's accessible via the Athens neutron monitor, the neutron monitor database. It's fantastic. Let's also take a look at Apatit and Barentsburg, since they are also exhibiting an uptick of cosmic ray flux for the past 30 days. So there you go. Apatit and Barentsburg, all of the monitors that we just showed, showing an uptick in cosmic ray flux for the past 30 days. We've also got a proton event here that's continuing. An additional spike here in the proton flux. So we've got energetic particles there circling around Earth's magnetic fields. And that's always interesting as it causes polar radio blackouts. And here's a visualization of that. So that's from the proton event, those polar radio blackouts. That's the attenuation of the D layer of the ionosphere, where your radio signal goes into space instead of being refracted back down to the surface. This is caused by solar energetic particle events, known as SEPs, which is reflected by the GOES proton flux that we just showed you. So a bit of a continuing stream of relativistic protons there, circling around Earth's magnetic field lines and causing polar radio blackouts. And it just increased, interestingly enough. So that's what's going on. And that must have been a result of this most recent flare. So, so solar energetic particles there showing up. And just having a small solar flare here, just leveling off here at 1120 peak flux there. It was a C2.87 class flare. And let's take a look at the past 24 hours. So here we've got 131 plus 171 angstroms. And let's change that out and switch to 94 angstroms. So there's our 94 angstroms 24-hour SDO video. And we'll also add 131 angstroms to show the two best wavelengths to show solar flares at the same time. So some events happening here right in the center of the solar disk. Just moving into the west are those active regions as we speak. And of course, you, the viewer, are encouraged to look up. By the way, things will look up as well. Our finest days lie ahead. One of the many facts we'll be citing here regularly on the Smash News Network, Least Busted Name in News. If you look up, if you're in Lehigh Valley, this is what you might see. As the sun has just peeked over the horizon there, chasing Mercury and Saturn across the morning sky, also the moon, high on the ecliptic. And let's do a solar system forecast before we talk about coronal mass ejections, filaments, and so on. So here's what's going on in the solar system. Earth is in a very lonely portion of the solar system. 0 planets over here, although Venus and Mercury are making their way to this side. Here's your 1-week solar system forecast. Keep in mind this imagery is not to scale. Approaching a new moon, we're about 8 days away from a new moon, which would fall on the 22nd, the first new moon of spring, as winter is almost over, folks. So here are some coronagraphs. This one includes the CME event from yesterday. There it is. A very high-speed coronal mass ejection. So that's yesterday's imagery. Here's today's imagery so far, 31 additional frames. We'll also show some missing data from Stereo A and Soho Lasco C3. So here's our Integrated Space Weather Analysis Center. The ISW, the Integrated Space Weather Analysis. The ISWA, yes. The ISWA site. And we'll let that play through here. It's not particularly definitive. And one thing that's great about this is if we pause it right here, you can get a great indication of how close to Earth Stereo A is. Because look at the number of degrees. Here's Mercury, and then here's Mercury on Stereo A. You can see that's not very many degrees. So Stereo A creeping up on the Earth and providing less and less ability to forecast coronal mass ejection trajectories. Anyway, I just wanted to bring up the events to see if there is a new model here. So let me just close these out. We're going to bring up the CME Evolution Ensemble here. We'll use dynamic pressure. And there's the NASA forecast. It looks like that forecast does not include a Thursday impact, but it does include a minor impact for tomorrow. So anyway, everybody's opinion matters. No arguments there. Let's move on here to show our coronagraphs. There's yesterday plus today. That's a 24-hour video. Some CMEs happening there, additional CMEs, and those do not appear to be earthly directed. Great view of Mercury there, sliding across the bottom of the Soho Lasco C3 in blue. And there's a full zoom. And we'll zoom all the way in to show 304 angstroms also. These are all 24-hour videos, by the way. And it's almost time to move to bonus features. First, a 24-hour video in SDO 335 plus 171 angstroms. Just in case you didn't have enough imagery of the sun for today, we have loaded up the video with it. Next, we're looking at filaments here from the ground-based El Teide, Spain National Sunspot Observatory telescope. We still do have significant filaments in both the north and the south. If you'd like to name filaments, follow the hashtag #NameThatFilament on Twitter. And make sure you follow us on Twitter and let us know in the comments if you know what this is. If you know what that is, you get a gold star or something. Also, you can find the link to the Hemp Lucid free mushroom gummies giveaway. So check that out. It's a pinned tweet on our profile. Yet another reason to follow us on Twitter if you want to try out the Hemp Lucid mushroom gummies. Check them out. Here's the past 24 in SDO 211 plus 171. Shows great depth of the solar atmosphere known as the corona. The 171 angstroms shows the lower portion. The 211 angstroms shows the extended corona, providing great definition there. We are almost at our bonus feature segment, which bridges the gap between space weather and meteorology. Anyway, here are the past about 2.5 hours from the GOES 16 SUVI. Crown prominence still hanging out up here. That could be a filament to get a name. Anyway, let's move to bonus features, as we don't want the video to be too lengthy. So here is our satellite's community dashboard. We do have some surface charging hazards here moving into the Central Pacific, moving out of western Mexico there. Those surface charging hazards caused by low-energy electrons building up on the surfaces of satellites, hence the term surface charging. And let's take a look at the electron flux. Here's your GOES electron flux. You can see that cratering as we typically see during coronal hole high-speed stream impacts. And there is the forecast model. So no arguments there. NOAA expecting a continued dip in the electron flux, and I would 100% agree with that forecast. There's the one-year chart to put it in context from solon.info. The greater than 2 mega electron volt electron fluence. And we'll show the F layer of the ionosphere also. The layer located about 300 kilometers of altitude is the layer where that electron flux is measured using radiography. The GOES satellites are thousands of miles above that. Tens of thousands of miles above that, in fact. But that's what's going on in the F layer of the ionosphere, the bridge between Earth and space. We'll make sure we get a full run. And we'll also show the anomalygram. And we're seeing continued major high-frequency anomalies, especially in the southern hemisphere. So I anticipate that this is probably a predecessor to some sudden stratospheric warming, as there have been extended high-frequency anomalies there in the southern hemisphere. That's anomaly in megahertz from a 30-day median, by the way. And yeah, South Atlantic anomaly is just chilling here, remaining over the South American continent. The South Atlantic anomaly, we watched it move thousands of miles, and now it's back, where it's been for a couple of years now. Here come the latest images. That's 11:30 Universal Time ionogram and 11:30 Universal Time anomalygram. We'll also show the total electron content. It'll show you the free electrons between your GPS satellite and your GPS handset, which is a run of about 12,500 miles, by the way. So those free electrons can cause signal refraction, aka GPS errors. And here are the most likely places to see those. CTIPE stands for Coupled Thermosphere, Ionosphere, Plasmasphere Electrodynamics Model. That is the free electrons between your handset and your GPS satellite. If you're expecting large GPS errors and you're navigating, try turning on Wi-Fi location accuracy. If there are Wi-Fi hotspots around you, they might be able to help put together an accurate navigational plan. We'll close out space weather with the largest and latest 4 megapixel imagery of the closest star. Is that a sunspot? Looks like it is. But it's not. How deceptive is that? This one up here does have an umbra. So check it out. That's a new sunspot right there. It's quite small yet, but we do see a tiny little pore opening there. So that's something. And we've also got this new group right here. Looks like it's already beta gamma class. Indeed, it does have a leading South Pole umbra and a trailing North Pole umbra. So that's already beta gamma class. I think that was only alpha class when we did show prep. So that just shows you how quickly things can change. Do we have a new group up here? Nope. I think this is a sunspot as well. Small little pore opening there also. So looks like a minor uptick in solar activity here. Again, fasten your seatbelts because there's a long way to go to solar maximum and a lot of fireworks to follow. So that should be exciting. By the way, if you enjoy the content and you prefer to see it continue to exist and remain publicly visible for all to view, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We launched our own subscription services site back in October of 2021. because we needed additional capabilities. So smashomash.com/SmashTeam is our own personal subscription services site. Feel free to help us out with a membership over there. The gold membership is $9.99 a month. There's also a gold annual paid-up subscription, which is the best value. It includes complimentary merch. It's almost like getting 4 months of a gold membership free. You can also have a smashomash.com email address. If you'd like, Bill at smashomash.com, we can hook you up with that if you become a gold member. Also, we've explained the likely mechanism underlying the solar sunspot cycles to our gold Smash Team members. There's also a bronze membership, and we send out email alerts whether you're a paying member or not. Links at smashomash.com to all of that, as well as our social media sites. Also, link to the Hemp Lucid site. Make sure you enter the promo code SMASHOMASH if you should be doing some Hemp Lucid purchasing. Enter the promo code SMASHOMASH to save some dough on checkout. Smashomash.com is the homepage, and welcome to the Neo Renaissance. Congratulations on realizing the channel exists. We will be streaming on YouTube at about 5 p.m. on March 20th. You've got less than a week left of winter. What are you up to? Let us know in the comments. As we approach spring, the March equinox, and it's going to be an epic melt season once again, indeed, as we move to the realm of meteorology. So what we're looking at here is relative humidity. And what's relative humidity? Well, that's the percentage of dew point. In other words, relative humidity is how close you are to dew point. In other words, if your relative humidity reaches 100%, you should be seeing precipitation. So the next time it's foggy or raining or snowing or sleeting outside, and somebody says, "Wow, it's really humid," you can say, the relative humidity is 100%, because that is when water can no longer stay a vapor and must condense onto droplets. So relative humidity is a very important feature of Earth weather. Keep in mind, it's not real humidity, it's relative humidity, which is 100% of dew point. And the barometric pressure and temperature affect that relative humidity, not to be confused with actual humidity. Anyway, that's what's going on. Pretty moist over the Americas and pretty dry over Africa, Saudi Arabia, India, and Chad, and Australia. Also, Antarctica, the driest place in the world. Yeah, it's an upland desert. The driest place in the world. It's even drier than the Gobi Desert, folks. Pretty moist over Antarctica. Also the North Pole, kind of moist. Also the east coast of Australia, pretty moist. And let's continue on here to our regularly scheduled meteorology segment. So there's what's going on for surface winds of the eastern world. Here are the jets of the eastern world. The 250 hectopascal winds. Here are the 250 hectopascal winds of the western world. You know, the Americas. And here are the surface winds. And like we said yesterday, that low is still loitering here off the coast of Cape Cod. Next, surface winds of the central world. Africa, Europe, and the Middle East. And, of course, the jet streams, depicted thusly. And we're always interested in what's going on in terms of clouds and fog. This is the scenario over the Americas. The 3.9 nanometer infrared radiation satellite picks up clouds and fog when it's too dark to use a visible satellite. So we show it on the regs on the channel, as we regularly put out videos before it is light out. But that's the current situation from your NASA Goes Interactive weather station. Next, your weather.gov weather station. If your location is lit, click your location. We've got lots of storm warnings there up the East Coast and some freeze warnings in the Southeast. Weather.gov is the place to go if your county's lit. Just click your county and get your weather alert. There are a little bit too many alerts for us to cover on this video. So here comes some forecasts. This is the GFS temperature anomaly forecast in degrees Celsius for the next 72 hours. We've got some warmer weather coming to Pennsylvania for the end of the week. St. Patrick's Day forecasted to be 68 degrees at the moment. Next, our pressure and precipitation forecast for the next 72 hours. It's the same model, the GFS. as moisture continues to get pumped in from the Pacific Ocean into California. Yowzers. Now that is a moist place. We'll also show the total accumulated precipitation forecast, since we've got several inches of rain forecast for large portions of California there. Also, some heavy precipitation coming to especially Massachusetts. That's your 72-hour GFS total accumulated precipitation in inches. And we'll also show the accumulated snow depth change. So there's your positive accumulated snow depth change in inches for the next 72 hours on the GFS model. Portions of California there, once again, expected to receive over 2 additional feet of snow. And here's a quick reference to the difference between the Euro and GFS model. There's, let's see, rain accumulation for the next 3 days, GFS model. There's rain accumulation for the next 3 days, Euro model. And what about new snow? There's the new snow Euro forecast. And there is the new snow GFS forecast, windy.com. Check it out if you don't have it installed on your mobile junkware device. Windy.com is not junkware, no matter how crappy and pathetic and barely functional your, quote, smartphone and, quote, device's barely functional software is. Here's our NASA Goes Lightning Mapper. And it looks like Miami may have seen some thunder and lightning, at least close by. Also the Bahamas. Let's check for current strikes. No terrestrial strikes in the U.S. at the moment, it looks like. Although a strong storm here in the southwestern Gulf. Heavy thunderstorm there. A very active cell. Anyway, that's your real-time lightning map. Next time you hear thunder, check it out. Convince the natives that you're Zeus or Thor or something like that. And here comes the U.S. Doppler radar map. Now we're looking at vertical motion of water droplets and ice crystals in the air column. A little bit of precipitation there around Alaska, and a lot of precipitation around the Northeast. So as that low hangs out and loiters off the coast of Long Island, heavy precipitation there in California once again. Here's clouds and fog over the lower 48. And you should see some great indication of the location of that low. And it's actually getting inundated here by some dry mass of air, which is creating huge pressure gradients. And it's tamping down the rotation big time here. So the low is right about there. Right about there. And it's just going to hang out here for a bit. This dry mass of air is going to want to swirl around it. And that's going to also help constrain it as opposed to pushing it up to the northeast. Anyway, here's our recap. Vertical motion in the air column depicted by the U.S. Doppler radar. That's radar.weather.gov. There is clouds and fog, 3.9 nanometer infrared radiation satellite. And there is the water vapor scenario over the lower 48. And that is where we will close things out. So thanks for tuning into the Smash News Network, Least Busted Name in News. Congratulations on realizing the channel exists. We're frankly surprised that you are, despite this content being the pinnacle of such content on the internet. There is no competition. So whatever. Congratulations on realizing the channel exists. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Please do not forget to visit links here and here and here.